Hello. Woo! Right. So, I want to talk about the magic of small things from microservices 10 years on. Now, I'm looking, scanning the room. There's some people who are as old as me, not many. So there's going to be a slight history lesson in here as well. So I'm going to talk a bit about the state of software engineering 10, 12 years ago. I'll then talk a little bit about how those sort of forces that were acting at the time led to what we now call microservices. I'm going to cover off some of the principles or the properties of microservices that Martin, Fowler, and myself originally talked about, described in our paper in 2014, and then I'll make some observations about where I think things are going. So that's what we're going to do. If you expected something else, Chris Richardson is really good. He's in the big room. He's also talking about microservices and team topologies, which is one of the things, of course, that's come since. So without further ado, I should probably introduce myself. My name's James. I work for this lot, Thoughtworks. It'll be 20 years in December. We're a consultancy. We do bespoke software engineering. We've got some awful tagline at the moment that involves AI. I shouldn't say that on camera, but we do. I'll get shouted at. We used to have the tagline, "The art of heavy lifting," which I really liked. It was like the original logo was an elephant holding up the world. Was it? No, it was a developer, sorry, holding up an elephant. There you go. And I quite like that. I quite like this, the art of heavy lifting. So that's kind of what we do. Hard problems. We're expensive, I've got to say, but we solve hard problems for our clients, including people like Google and so on. So but I've been there quite a while, and over that time, I've worked in many, many different technology stacks. I've worked on different domains, from retail banking to insurance to retail, bricks and mortar to e-commerce, et cetera, high-frequency trading, front office trading, etc. So, and I think I've written production code in Java, Scala, Clojure, C#, Python, obviously Python, because Python is all the things these days, right? Everyone has to write Python. That's running the world now. Python is running the world, which is good, because it was going to be Ruby at one point, and Python's way better. So that's me, a bit about me. But yeah, the magic of small things, microservices 10 years on. So there's some stuff at the time that we were thinking about. When I say we, me and my colleagues, I guess, the people I was hanging around with in Thoughtworks at the time. But not just that, like the industry as a whole, right? There was a whole bunch of stuff going on in sort of 2009, 10, that you probably, if you're old enough, will recognize. And if you're too young to recognize it, you're lucky, basically, all right? So to start with, most enterprise software was big and hard to change, right? This is, we're thinking like, we talk about monoliths now, but at the time, everything was a monolith. Every piece of software, more or less, was a big piece of software that evolved into big balls of mud over time, and that was hard to change. This is a diagram. This is actually what Thoughtworks internally looked like back in about 2009, our internal systems. You don't need to take anything from this, apart from it's a bloody mess, all right? But most enterprises were the same. Most enterprises had big databases with lots of stored procedures. They did direct database-to-database access. Things were, every time you wanted to change something, you had to change things everywhere else. The blast radius was the entire stack. It was a bit of a disaster. I quite like the fact on this. If you look hard enough, in the middle here, there's something called the middleware database. Now, famously at Thoughtworks, we're sort of averse to enterprise service buses. In fact, my former colleague, Jim Weber, he coined the phrase egregious spaghetti box to talk about enterprise service buses. Because what he said is, they're great, right? Because the architects love enterprise service buses, because what they do is they take a diagram with loads of lines between systems crossing over one another, and they make them all point to a single box. So your diagrams look lovely, right? The problem is, inside the box, it's all still like spaghetti, right? Egregious spaghetti boxes. And someone had got the memo about not liking them, so instead we had a middleware database where we did all the integration, which is sweet. I believe the phrase is the cobbler's children have no shoes, right? You know, we were doing all this really cool stuff for our clients. Internally, we had middleware databases. But things were big and hard to change. And this is, this was true pretty much every client I work with from the start of my career up until, well, now, actually. Still, most organizations have these big, messy infrastructures, but some are better. Much of the software tooling that we used at the time was really heavy and sort of enterprise-ready tooling, right? You had to pay licenses for things. There wasn't, the open source was pretty nascent. And so you had a bunch of these sort of big, fairly heavy application servers like JBoss and WebSphere, yeah, that's a Freudian slip, WebSphere. You had big databases like Oracle Application Service, IIS. You had things like ClearCase. Hands up, anyone who's even heard of ClearCase? Okay, like the pain, people are shaking their heads, the grimaces of the people who've put their hands up there. If you don't know what ClearCase was a version control system, which was like a centralized version control system, where you had to have an administrator to administer your version control system, right? It was really, 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 really difficult to use. The cool thing is that what you would do is you'd check out a change set of the files you wanted to work on, and that would lock those files in the central version control system. So you would work on your files, and then you would go away on holiday, and no one else could work on those files until you came back, which is like perfect, right? Amazing. So that's ClearCase. Mercury Interactive. Mercury. Anyone remember Mercury? Yeah, we've got someone at the back who's also grimacing. So Mercury was a testing tool, like a point and click. You'd record your journeys by pointing and clicking, and then it would replay those journeys for you, which, if you've ever done any form of testing like that, it's a very, very brittle, flaky way of testing things. So Mercury was the main testing tool at the time, both for rich clients and for the web. Yeah, so pretty heavyweight stuff. Integration as well. I mean, we're at EventCentric, at the EventCentric conference. Obviously, things have moved on a lot since then, but this is the web service, WS star set of specifications. This is like SOAP, document-oriented SOAP, for example, or RPC, or SOAP RPC. This is where this was all specified. You had a specification in here for the specifications. That's how heavy enterprise integration was. If you don't remember, what you used to have to do is you basically generate something called a WSDL file, which is a ton of XML. You would then use that to generate a set of libraries, which you could use to talk to the service. If this sounds like Swagger, yeah. But hey. But the key thing about this is you were binding at build time. So you would generate a set of libraries, and you would include those libraries in your build. And as you built, when you deployed your software, you could talk to a remote service. Problem is, of course, if anything changes, you've then got to rebuild your software, rebuild the libraries and rebuild your software. Big and heavy and complicated. Loads of the things we sort of take for granted now, really, was sort of controversial or new at the time. So I'll go through a few of these. So the middle one, this is extreme programming. This is what you get if you ask an AI image generator for extreme programming. You get someone sitting on a cliff with a laptop. But a lot of these things were new. The Spring framework was new in sort of 2000, I would say sort of 2006, 2007, that sort of time. And whilst these days we think of Spring as fairly heavy in itself, it was definitely better than the alternative in Java land, which was J2EE. Things like Tomcat, so lighter weight open source application servers, were also new. JUnit, unit testing, TDD, these were techniques that were only starting to become more widely used back in sort of 2008, 2009, that sort of time. AWS, I was the first ever fourth, actually, I tell a lie. So Sam Newman, my former colleague who wrote Building Microservices, myself and him and two others, we were the first 4 AWS trainers globally back in 2011. So that's when the sort of climb of AWS started. But of course, it started in about 2007, 8 really. But back then, AWS just had basically buckets, and it had instances, and it had maybe, if you were lucky, a database. Obviously, now it's grown into this behemoth. Trunk-based development. Now, I'll die on this hill. Trunk-based development is the best way to develop software. You can take your pull requests, all you youngsters, and you can shove them, basically. Trunk-based development, by which we mean having a always deployable, having your code on the trunk always deployable, is where continuous delivery came from, and where continuous deployment came from. Having the ability to be able to say, yes, this is the current state of our software, and we can deploy it immediately. Again, that's taken a backward step, to be honest. This is, given we're at DDD Europe, or associated with DDD Europe, this is a line from a talk I did with Dan North in 2009. Yeah, it's too low. It says, actually having a domain model was new. That was a new idea, right? Actually having a domain model was a new idea back in sort of 2008, 2009, 10, right? Because objects are expensive. Objects would lead to performance problems. We can't create loads of objects because the JVM can't handle it, for example. And so we would use ints and strings and blah, 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 not relying on typing. Actually having a domain model where you might have a user, and the user might have an address, and the address might have a first line and a second line and so on. These were new ideas, would you believe? Probably not, looking at your bemused faces. Like, we're at DDD Europe, James. Like, we know what a domain model is. But this, honestly, was a new thing, really. It was relatively new. Developers and operations, best of mates, clearly. That's changed, isn't it? Now we just call operations DevOps, but they're still the best of mates, unless they're in a platform team, in which case we call them platform engineers, and that's fine too. But developers and operations, there was the classic thing. Jess Humble, author of Continuous Delivery, and another former colleague, he used to say, it's amazing what happens when you get a bunch of people who are optimized for change, doing stuff, and then a bunch of people who are optimized for not change, and then you ask them to collaborate together. That's basically the tension between developer and operations back in those days. I mean, things have moved on, fortunately. The DevOps movement was started by, of course, Patrick Dubois, but another person I'll talk about in a minute. So that's the sort of scene. That's sort of where we were back in 2010, that sort of time. Big heavyweight software, big software tooling, big heavyweight application servers, big heavyweight databases, big monolithic applications, often integrated using sort of awkward, shall we say, technologies that were hard to change. So it was kind of the right place at the right time for something to happen. Now, I'm going to caveat what I'm going to be talking about next, which is to say this is my story about what happened next. There are many others. You've probably come across the idea of convergent evolution, where two different things happen in different places simultaneously. And I think this is what happened with microservices, and I'll talk to that in a bit, where a bunch of people in different parts of the world had different ideas about how to solve some of these problems, how to proceed, but they all came up with essentially the same set of solutions to them. But it was the right time, it was the right place for something to change. Alea iacta est. Obviously, everyone knows Latin these days. Do you know? Did I get that right? The guy who knows Latin? Yeah. Alea iacta est. Yeah. It's the die is cast. So this is what Julius Caesar said when he was standing on the shores of the Rubicon, when he was about to enter Rome with his armies. And this was to take control of the Republic, essentially, become emperor. The die is cast. He took a step into the river and said the die is cast because there was no turning back. Once you took armies into Rome, that was an irreversible step. So it was the right time, the right place, and this is what you get if you put the Rubicon into GenAI. I'm going to have some GenAI into it. I don't know. That's all, I promise. Alea iacta est, the die is cast. So I should talk about a couple of people who were involved at the time as well, because this is all about standing on the shoulders of giants. And it's not fair to claim that Martin Fowler and myself invented microservices, because many of the ideas that sort of became adopted as part of the microservices style of building software originated elsewhere. I think of microservices a bit like extreme programming, where you take all the good stuff and turn it up to 11, right? That's the kind of microservices idea. So I'll talk through a few of these. I won't talk to all of them. We have Eric Dernenberg here in the red T-shirt. He's our European CTO at the moment, long-term thought worker, but he's been around in the software world for well, I started working with him in '99. He's the maintainer of OCMock, which is the main mocking, or was the main mocking library for Objective-C and CC-Tray and various other things. But he was absolutely an inspiration when I was working with him. Evan Botcher, he wrote a lot about platforms and platform engineering, even like 5-6 years ago, maybe longer. Obviously, we've got a bunch of books, Continuous Delivery, Jez Humble and Dave Farley. This is about how we safely and sustainably deploy software, build software, with all the patterns that we look to now, things like Canary, releasing, dark launching, all these things are in continuous delivery, build pipelines. Obviously, the Blue Book, you've probably all heard the story about Eric Evans preferring, wishing now that he'd written the second bit first. I did ask him, and he said, yes, I should have done that. So that's from his mouth. But strategic design was a huge inspiration on microservices, I think. REST in practice, how can we simplify integration? How can we simplify the way we talk between systems using the biggest distributed system, or using the techniques from the biggest distributed system we know, which is the web? Enterprise integration patterns. Obviously, Gregor was here yesterday. I think he did the keynote yesterday, didn't he? Which is still the canonical work on messaging. And then we've got Sam Newman, who wrote Building Microservices, who was my build monkey on a project I'll talk to in a minute. Daniel Terhorst North, behind BDD, who's a huge inspiration to me around how you build RESTful services. Chris Reed, who co-created DevOps and is the sort of mildest mannered person who doesn't seek the limelight ever. But he was one of the people with Patrick Dubois who created the first DevOps days. And that's where the name DevOps came from. And then Release It, Michael Nygaard. So how you can use patterns like circuit breakers, bulkheading, all these things to make our systems more more reliable, and available, and so on. All this was happening at the same time. All these books, all these people were working in London, or adjacent to London at the same time, in around 2005 to 2010. There was this huge explosion of innovation, in particular in London, and in particular in Thoughtworks London. I'm going to brag and say that because it was true. In fact, Michael Nygaard, I was at an event with him recently, he said the only equivalent that he could think of to Thoughtworks London in 2005 to 2010 was Bell Labs. The sheer amount of innovation that was being driven by the people in the company I work for. Because you've got microservices, you've got BDD, you've got DevOps, you've got platform thinking, you've got continuous delivery. All these things actually came from a really small set of people who were working together, talking about stuff in the pub in the evenings, and traveling to clients on trains, talking about things. I do wonder, this isn't a sidebar, I do wonder about remote working now, and whether we're going to see a drop in innovation as a result, if you don't get a bunch of people together who are passionate and interested and want to solve problems collaboratively. I wonder what's going to happen over the next 5 to 10 years because of that. I guess we'll have to see what happens, but I worry. Anyway. Then what happened was I was working on a project. I just started working on a project for a loyalty management company. So loyalty management is a really interesting domain. It's retail, basically. Retail banking, basically. Right? So you have accounts, you have people, and so on. And then I was lucky enough to be invited to something called the Software Architecture Workshop in Castelbrando in 2011, just north of Venice. And this is an unconference, right? So it's a 3-day unconference where people are invited, a bunch of architects from around Europe, interesting people, to talk about whatever's on their mind, it being an unconference, an open space unconference. And the theme of this unconference that year worked out to be, why are things so broken? Why are things so big? Why can't we change these things? Techniques that we could use to help maintain big pieces of software, tools to do that, and so on. And then I had a sort of light bulb moment on one of the evenings, which is, what if we're solving the wrong problem? What if the problem that we're trying to solve, which is big things and maintaining them, is the wrong one? And actually what we should do is build small things which we can throw away. We don't have to maintain. And originally I actually talked about to the level of aggregates, these really tiny services where each aggregate was its own service. It's slightly different these days, clearly, but that was the original sort of intent. What happens if we have this set of a set of processes that are based around aggregates that are communicating using simple, lightweight protocols? This is Castelbrando. You can't really see that. It's a bit dark, but people who are fairly well known, probably to you lot, that's Udi Dahan from the of End Service Bus fame. That's Gregor. Dan North was there. Stefan Tilkoff, who is very big in RESTful service-oriented architecture kind of world. A bunch of people who, I guess, from different schools, if you like. Jimmy Nielsen, domain-driven, who'd just written domain-driven design applied in .NET, whatever the name is. So a bunch of people from these different schools coming together to talk. And at the end of this, the idea was that maybe we should create smaller things, micro-apps, we called them. And then later on, the name became Microservices. The reason it became Microservices is because Martin liked microservices, Martin Fowler, and when Martin gives something a name, it stays named, basically. That's it, you're done, right? It's now canon. So, yeah. Talking of whom, would you buy a used car from this man? This is Martin Fowler, my friend and chief scientist at Thoughtworks. So he turned up at this project I was on. He's brilliant at sort of, I think that in open spaces they call it like bees. They sort of hop around between different conversations and sort of get lots of the interesting ideas and spread the interesting ideas. He's brilliant at doing that. And so what Martin does with Thoughtworks is he goes to our projects and he finds interesting people to talk to about the work they're doing, and then he sort of helps them write it up or writes it up himself. He's very clear that he's not a software developer anymore, unless you count the 15-year-old Ruby scripts that run his website, which is statically generated, incidentally. It's all hosted in S3, it's static. But he's very, very good at doing that, at getting interesting ideas from people. So he came to visit my project in 2011, and he said, this is really interesting, we should write this up. People would be interested in some of these ideas, right? Now, the problem is I'm a terrible procrastinator. Everyone thinks I've written a book. I haven't ever written a book. And the reason I've never written a book is I just can't. I just procrastinate to the point that I can't start. I don't know if you know the English author Douglas Adams. He wrote The Hitchhiker's Guide to the Galaxy and other books. So he used to say, I love deadlines. I love the sound they make as they whoosh past. Right, when it comes to books. And I'm very much the same. They just, phew, oh yeah, I should have done that by now. Yeah, no. And I'm the same. But Martin managed to persuade me. Actually, what he did was he invited me for a sleepover. So I went for a sleepover at Martin's house in Boston for 2 weeks. And at the end of the 2 weeks, we'd written up the article that became the Microservices paper. Yes, so I don't know, has anyone else been for a sleepover in Martin's house? I'm going to... Yeah, you have. Yeah. Oh, that's cool. You were joking. Oh, damn. I used to do this thing at talks where I'd say, okay, who knows who Martin Fowler is? Everyone's hand would go up. Okay, like who's met Martin Fowler? Some people's hands would go down. And then, okay, who stayed at Martin Fowler's house then? And I did it once at Yao in Australia, and Dave Farley was sitting in the front row, and he kept his hand up. I was like, I thought, what do I do now? Okay, whose father is friends with Martin Fowler on Facebook? And he had to put his hand down there. Random. Anyway, sorry. Random anecdotes. So I went to Martin's and wrote up this stuff about this project I was on, which I first presented at QCon San Francisco 2012, Microservices Java the Unix way, or what I did last summer, how we designed and built a resource-oriented, event-driven system out of applications about 1,000 lines long. So, the first microservices thing I was involved in from end to end was event-driven. It was based on REST. You can do event-driven using REST, would you believe? REST in practice is all about how you can do that, how you can create queues using things like atom feeds or link, whatever, or OData. And you use competing consumers with conditional gets and puts, all this sort of stuff. You can actually build very sophisticated event-driven systems using request-response semantics. But that's what we did in this project about a loyalty management system. And in that, I said a few things. Each microservice should be small with a single responsibility. Each application does one thing, small enough to fit in my head. It's small enough that I can understand everything about the thing, right? It's a restatement of the single responsibility principle. Small enough that you can throw them away, so you don't have to maintain them over time. Located in different version control routes. So by this point, we'd adopted Git in most of our projects. We'd sort of beaten out Mercurial in terms of distributed version control. And we sort of said, hey, let's put every service in a different Git repo. Right. And the reason is because I am stupid. Like, literally. Well, I'm kind of smart stupid. So I'm quite smart, but I'm also really dumb. What do I mean by that? Well, the problem I have with big repositories is not the big repository per se, it's the fact that I see abstractions everywhere. I always break the rules that I should be using in order to apply domain-driven design, for example. I'll say, hey, this user in this part of the code base, or this customer object, it looks quite like this customer object in a completely different subdomain. Oh no, I'll just put them together, right, and put them in a library, and we'll be fine. But of course, over time, what happens is two different parts of the code base evolve independently, and you end up with a single God object, a single customer object, where you have to change everything. All changes have to happen there. And that's me. I just can't help seeing abstractions. Right? Rather, I can't help early abstractions, like abstracting too early. So if you break stuff up and you have customers over here and customers over here, well, it's harder to bring these things together. So that's why we're in different version control routes. Containerless and installed as well-behaved Unix services. Remember, at the time, we were used to things like JBoss, we were used to things like WebFear, even Tomcat were fairly heavy, or IIS, fairly heavyweight application containers. Not containers in the sense of containers as we know them now, but application containers, where you'd build like a WAR file, or you'd build a DLL, install them into a thing, and that thing would run it for you. Instead, what we said is, why don't we use use Jetty or use an inline HTTP server, include that in our jar files and just execute them on the command line. And that was a kind of new idea back in 2011. Strange to think now when the world has moved on, but that's what we were talking about. And then provisioned automatically, the ability to stand up entire environments as Phoenix environments. This is the start of the cattle, not pets idea behind Cloud Native. How can we stand up an entire test environment and then tear it down when we don't need it? Entire production environment, tear it down when we don't need it, declaratively from the command line. So this was the finale, if you like, of that talk. Consistent and reinforcing practices, hexagonal business capabilities composed of microservices that you can rewrite, which form a distributed bounded context, deployed as containerless OS services, standardized application protocols, and auto-scaling and design for failure. So you can see in each of these lines almost a thread from the different giants that we were standing on. You can think about hexagonal business capabilities. This is Alistair Cobin's work on that, but then also going back to a lot of the work that Microsoft were doing around service-oriented architecture around business capability mapping. Rewriting and then, rather than maintaining, this is from that sort of event I was at. Distributed bounded context obviously from DDD, and then the cloud native ideas coming through as well, the nascent cloud native ideas. I should point out, this is my story. Convergent evolution, there were a bunch of other people who had similar ideas at the same time, right? So I think of this group, we are all the grumpy uncles of microservices. Chris Richardson also probably should be on here, but there's only space for 4. So sorry, Chris, you're not here. Stefan Tilkoff, who's talking about self-contained systems. Daniel Terhus-North, replaceable component architectures. Adrian Cockcroft, who was at Netflix at the time, was talking about fine-grained service-oriented architecture. And Fred George talking about programmer anarchy and nano-services. Tiny, tiny services, 50 lines long. Now, the funny thing about this is I talked about Thoughtworks, and I don't want to big Thoughtworks up too much, but I am, sorry. All of these people are friends or associates of people working at Thoughtworks at the time. So Adrian knows Jim Weber and Ian Robinson very well from who wrote Rest in Practice. Dan North, ex-Thoughtworks. Stefan, he's part of that group at the Software Architecture Workshop. And Fred is also an ex-Thoughtworker. So all these ideas sort of converging. Do you know what? The world is quite small, actually, with what we do. And this is why these events are brilliant. This is why the hallway tracks are so good. Because we get to share these ideas, and these ideas morph and turn into other things, and they get spread to other events and other conferences, and we talk about them. And then what happens sometimes is you get these interesting things occurring because of that. So convergent evolution. And this is what we ended up with, a set of characteristics. We wrote this 2014. These are the characteristics. So I'm going to talk a little bit about a couple of these. Obviously, I'm not going to talk about all of these because there's a lot of them. There's a lot to say about them, but I'll cover off some of them. I'll talk a bit about some of these ones that are not grayed out. The first one is this idea of componentization via services. So we defined a component as something that was independently replaceable and upgradable. Not deployable, but independently replaceable and upgradable. And it turns out an easy way of doing that is to run things as separate processes. So if you've got independently deployable processes that are upgradable and replaceable, that's what we meant when we said componentization via services. It's very much related to the roots of object-oriented programming. So Alan Kay, much later when he was asked about what OOP means to him, he said, it means only messaging, local retention and protection, hiding of state process, and extreme late binding of all the things. And that's kind of the idea with microservices, right? We want to be having these processes that are running independently from one another. They're communicating via messages. Sometimes that's request response, but communicating via messages. They're encapsulating a single idea, single responsibility, single reason to change, which was the original definition of single responsibility, and they're extremely late bound, right? So we can change them and deploy them independently of other things, right? This is the thing we didn't stress enough, I think, at the time, is that these things should be independently deployable. If you have to deploy another service and you have to redeploy your service, like, in general, that's kind of a failure mode. That's kind of an anti-pattern, a bit of a smell, and a signal that actually these things that you're building aren't microservices. So how do you do that? I mean, there's lots of techniques these days to do that in terms of schema versioning and so on, and eventing. At the time, we were very big on REST and using expand contract contracts to do that, expand contract interface pattern. But this is essentially what we were talking about, the original definition of OOP. And this comes back to this located in different version control system routes. By keeping things separate, by only sharing infrastructure code, so we would share libraries, we would share basic things like HTTP clients, but never any domain code, ever. That's sort of fed into this idea of extreme late binding of all the things, as opposed to binding at build time, right? We bind integration time. There's a drama, should we say. I don't know if you've come across this dilemma of how to define your services? Do you define them as nouns, or do you define them as verbs, things that do things, or things that are things? And that's one of the things we didn't comment on, I think, and we should have done. This is sort of emergent afterwards, is the fact that if you define services, if you build services that are things, customers, orders, and so on, what you end up doing is creating a tangled mess where everything has to change all at once. Often the change boundary when you have nouns sort of encompasses all the nouns, as opposed to if you have services that are doing things, the change boundary is just those verbs. Michael Nygaard wrote a brilliant post about this, the entity service anti-pattern, a long time ago now, 2017, and then even longer back in 2007 in Dan North's post, A Classic Introduction to Service-Oriented Architecture, which is brilliant. I really recommend you looking at. This is 2007, I think. Yes. He talks about how you build service-oriented architectures based on verbs, based on things doing things as opposed to things that are things. As an example of that, he talks about how you book a holiday. If you're in a company in the 1950s before computers, right? If you think back to 1950s, there's no computers. How do you book a holiday? You can't use the intranet. What you do instead is you find a form, a paper form, you fill in your holiday request, you put it in your outbox, internal mail person picks it up, takes it to the HR department, the holiday request people, right? The HR department gets it in their inbox, they pick it up, they go, yes, you can do that. They sign it off, put it into their outbox, and it comes back. An asynchronous process, basically eventing, more or less, right? This is messaging. And this is how Dan was talking about building service-oriented architectures back in 2007. Now, I should point out, in terms of componentization, in terms of how big they are, microservices, I've still no idea. I don't think anyone still has any idea. The main thing for me is that back to the definition of OOP, they encapsulate state, and essentially they don't do distributed transactions across multiple entities. Right? So if you ever end up in a scenario where you're trying to do distributed transactions, smash things together, otherwise, well, who cares really how big they are, as long as they're independently deployable. Organized around business capabilities. So back to SOA again. This is Mel Conway. I did a talk years ago now where I was talking about, it was called How I Stopped Worrying and Learned to Love Conway's Law. Conway's Law, if you don't know, I'm sure everyone does, basically says that the shape of the software that a team builds or an organization builds mimics the organizational structure of the group of people who build the software. That's Conway's Law. And I had this idea that he was a Muppet, Statler and Waldorf, sitting on the balcony laughing at us, because 60 years ago he wrote that paper, and we still haven't learned the lesson of it. Right? So, he's just pointing and laughing at us. Many years later, I actually met Mel. He's a real person, turns out, and his wife. I met Elizabeth, and Elizabeth came over and said, "Are you the James Lewis?" I was like, "Oh my God." I said, "Yes." And she said, "I'd like to say thank you for those videos where you've got my husband as a Muppet." Like, okay. She said, "I showed them to my grandchildren, and they loved it." I was like, yes. Result. So Mel Conway is a real person. Organized around business capabilities. What did we mean by that? Well, business capabilities are the what of a business, right? They're the stable constructs that describe the things a business has to do, essentially. Not how they do them, but the stable constructs of the what of the business. It's an interesting thing, right? But this is from Microsoft Vision in 2010, I think, which is an enterprise architecture tool that Microsoft produced. And that is the top-level business capability model on your left-hand side. Every company looks like that at a high enough level. Right? The question is, when you drill down into these capabilities into level 1, 2, and 3, then what they look like. And there's some examples here. The point is that these are stable, right? If you're a retailer, you're always going to have to do a certain set of things. If you're a bank, you always have to do a certain set of things. So why not build your software around those certain sets of things and use those boundaries to essentially enforce stability within your software architecture. My former colleague Ian Cartwright, he always said that, he sort of says that if you look at your software estate and you look at your business and you can't recognize your business in your software estate, then you're doing something wrong. Your software should be organized according to your business capabilities. And that's why we called it out. Now, obviously, coming down the line, we're in the domain-driven design adjacent event. I quite like this. First, like any architecture, no competent architect would use them unless the pros, blah, blah, blah. Is there any competent software architect who can explain to me, like I'm 5 years old, what the pros and cons of having customers in order in a separate database are? And Dan replied on LinkedIn, it's basically a TED talk and a LinkedIn post. You should go and have a look at this. It's fantastic. But essentially what he's saying is that having customers and orders in separate databases is not the point. The point is that you can have customers and orders in the same place, but you might also have customers and orders in a different place as well, and they're different customers and orders, right? This is what domain-driven design is. This is essentially saying that we don't have to have a single representation of a thing, because the context of that thing will change depending on the software that's using that thing. Right? And that's all related to this idea of business capabilities. A customer or an order in fulfillment is going to be different from a customer or an order in your e-commerce site. Right? And that's okay. You don't have to have a single view of the customer. You can have different views of these things. And you can have translations between them, and you can cache them in different places and so on. And that's really this whole idea behind business capabilities and this, we called it a distributed bounding context back then. And this is my email I got from Mel Conway. He's not sitting on the balcony laughing. He's sitting at my computer learning from me. So this is what they call in rhetoric an appeal to authority. I know Mel Conway, so you should trust me. That's what I'm saying, yeah? But what we should have done is we should have been more explicit at the time with a link to domain-driven design. We should have actually talked about it a lot more. That's one of the real failings, I think, with what we did, with what we wrote up. We didn't talk enough about how you break things up, how you organize things, the importance of core domains and subdomains, and how they relate to service boundaries and so on. Right? Does a service relate to a single subdomain? Does a service relate to more than one subdomain? Do you have multiple services representing a subdomain, et cetera, et cetera? I mean, these are all valid patterns, and we didn't really address any of that. I'm sure, well, definitely since then, lots of work has been done on that, but yeah, at the time, we kind of missed it a bit. Yeah, please. So the question for the rest of the room and for the video is, it appears that an order of magnitude or more people know about microservices than do about domain-driven design. And if we were more explicit, do we think that maybe that balance would be different now? Maybe, I don't know. I don't want to. I don't want to sort of lay claim to how influential what we said at the time was. I'm just sort of talking about what we did, really. Maybe. I mean, I do know that when I was doing training over many years, even the Blue Book at the start, you'd have most of the room would have read the Blue Book. And then by the end of the training, 7, 8 years later, you'd get one person out of 30, you know. So I don't know, maybe. And as I say, it's a bit of a miss on our part not to be so explicit, really. Which is a shame, I think, because it does lie at the absolute heart of microservices, at the heart of the idea of how you break things up into stable units where you can throw them away if you need to, although that's not really happening. But these stable units that are organized around your business concerns, and the idea that you've got that it's okay to have different representations of a thing in different places is really not very well understood at all. Yeah. I've got another question.
Yeah, connected to that, don't you think that the importance of domain-driven design and business capabilities has been missed? Because what I see is that a lot of people, they basically get that business capability is going to define the boundary, and that indeed, like you say, there are different representations of what a customer is within those different business capabilities is generally not understood.
So the question and observation is that maybe it's the fact that we didn't make, or that the link between domain-driven design and business capabilities isn't explicit, or isn't explicit enough, has led to maybe this. Yeah, potentially. Yeah, I mean yeah, potentially. Yeah. Okay. So I'll come on to a bit about what I wish we'd done differently. This is one thing, make that more explicit. I think we reinvented a lot of stuff. This is Greenspun's 10th rule. I don't know if you know this. Any sufficiently complicated C or Fortran program contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Common Lisp. But Dan North rewrote that as any sufficiently complicated microservice implementation contains, etc., of Erlang. Right? I mean, a lot of the things we were building is reinventing a lot of the stuff that already exists in other programming languages and other programming paradigms. A lot of the stuff we're doing, you could do in Erlang. This is especially true now when we're talking about agentic systems. I mean, turns out Erlang is agents, right? Erlang's agentic. We've got Akka obviously sponsoring here, and Akka is very similar to that, right? Agent-based systems. So you could slash /s/Erlang/Akka in there as well. So that's one thing. Did we reinvent the wheel? Infrastructure as code, that's still a mess after all these years. So that's one thing I don't think that we've addressed as an industry. We've got lots of infrastructure code, and it's still a mess. Right? It's still reams and reams of JSON or YAML or whatever it is without sufficient abstractions, and which is still difficult to work with in general. We still haven't learned the lesson about single integration testing environments. We still want to deploy everything and test everything together. Like where the whole idea was you should be able to independently test and deploy these things on their own. And the name. I think the name was wrong, unfortunately. But as I mentioned, when Martin names something, it stays named. Because the name talks about size, and it's nothing to do with the size, really. It's to do with domain boundaries. It's to do with encapsulation of state. It's to do with single responsibility principle. It's not really to do with size. What did we miss? Well, I talked about domain-driven design, but also we missed a lot of the cloud native stuff that was happening. We didn't really talk to that. We didn't really talk about continuous delivery, the importance of being able to have always deployable software sitting on the main line. And we didn't talk about the importance of being this tool. And what do I mean by that? This is Sam Newman wrote a brilliant article on that you have to be this tall to use microservices. If you haven't got continuous delivery, if you don't do automated testing, if you don't have these practices in place, then it's going to be very, very hard to adopt a microservices architecture. Another way of looking at it, or another aspect of that, is the set of requirements that you need in order to use microservices are much, much smaller than you think. They tend to be around how many teams you need to build software. They tend to be around how scalable you want your software to be in different areas, the rate of change of different parts of the software. It's not a single one-piece-fits-all style of software architecture. The other thing we missed is this. We didn't talk enough about independent deployability by a stretch. This is still the most common failure mode of most microservice implementations that I see, is the inability to deploy them on their own. And then you end up with this distributed monolith, distributed big ball of mud. And you end up in a worse position than you were before you started. So I wish we talked a lot more about that. At the end of our article we wrote, we asked this question: are microservices the future? We said, it's cautious optimism, maybe yada yada yada. It's too early to say. Like 10 years on, I think it's the predominant way that people build software these days, or most organizations build software. And there is some research to show that it's had positive impact. So this is from Accelerate. So, the set of research that came from the State of DevOps reports, where is it? Loosely coupled architectures lead to substantial increases in all the things. So maybe there's some research that says we've gotten better at building software by adopting these loosely coupled architectures, of which microservices is one. And I did promise something about the future. The future's robots. That's it. Thanks.